Hello, everyone. Welcome to the RPM Rundown. I'm Dave Klubeck, our Director of Data here at RPM, and this is our 5th episode where we'll be talking about data, technology, and innovation in the logistics market. I'm joined by Eric Young, our Lead Engineering Manager, and Rick Grubb, our Chief Information Officer for RPM. How are you guys doing today?
Great. Good. Happy to be here. Can't wait to get started.
Yeah, let's get into it. Cover an article from Siva Logistics. The article discusses how data is the key asset in logistics, driving better decision-making and operational efficiency. The idea behind it and what the article generally covers is data laking and data centralization so that you can master the data and provide it both transactionally to your applications as well as business insights. Enables everybody to have access to the same data at the same time and make decisions based on it with full transparency into the intelligence of the business.
I think in a lot of industries, just having a lot of data is known to be kind of the key to success, and it has been for a while. But coming to the logistics industry a few years ago, it was similar to government, which is also in my background, where everyone knew that having a lot of data was helpful, but nobody actually had it. So now for the last, let's say, 5 to 10 years, they've been revolutionizing their data architecture and starting to collect the data they need to make informed decisions, as opposed to just kind of making business decisions based on somebody's like personal experiences or what they're reading or whatever. It's actually data.
It's the
data driven.
Yeah.
But you've been in the data industry for kind of a long time, given how like the age that we're in. So what have you seen?
Data silos.
Over the years.
Tons and tons and tons of data silos. And I think what we start to do is there's a level of maturity that a lot of companies get into where they look for a flag in a column that says something like is deleted. And the reality is, it's not just about how the data comes to you from, say, a vendor or how you collect it, but it's also about how you start to monitor and observe the data as it's flowing through to you. I'll give you a great example. Like you get an array from a vendor, but the vendor itself isn't necessarily going to create the tracking that you need for your reporting, but being able to monitor that same, let's say, shipment and understand the difference, what we call CDC, the change data capture, between those two packets of data and how that shipment changed actually tells you something about the behavior. I think a lot of data today in companies wants to be focused on behavioral analysis, but you actually have to have people who are dedicated to the context of understanding it to really understand how to make decisions around it. Otherwise, what you have are like lag metric dashboards. You have a Power BI dash that's telling you how much volume you moved yesterday. And that has such a finite amount of actual insight power.
It actually makes things worse, I think.
Way worse.
The amount of quote-unquote KPIs you have on a dashboard to show what's happening right now, that's just information. It's not actionable.
100%.
And people get used to this information and they want more and more information. You know, when I first got here, I sort of likened it to we have so much data, but it's like a dark attic.
Yeah.
And someone's got to go up there with a flashlight to try to find the thing they want. And I'm not sure we figured it out, which is why we hired you to come help build this. But reading the article, I'm just sort of struck by a little bit of confusion. And I want your take on it, Dave. Like, all of that has been that same stuff, data lake, all that stuff, has been the buzzwords for years, maybe a decade at least, around the IT space. You know, why do you think it makes any difference now in the logistics space, or why that article now?
So this article to me is an indicator of something, a pattern that I've started to see over time. And the first one is, I think we talked about this. I got started when Hadoop first hit the market in about 2010. That was sort of like my peak crescendo, like moving into my career. Big data was a thing at the time. Nobody knew what that meant. And it just meant there was a bunch of internet data that you could go grab now. The last 10 years have been about companies trying to figure out what the hell cloud is. And everyone's had different patterns for it. Prior to that, in on-prem, we've had patterns for 25 years about how you wanted to set up your DBs, 10 years of data warehousing as we discovered Power BI in 2000. And then all of a sudden, everybody introduces the cloud, and you have 100 different systems, 100 different services, 3 different major cloud providers, and they're offering you things that all look the same, but have no known patterns or structure for how they should be built. So people were either lifting and shifting into the cloud. People were either innovating and creating a lot of noise and an even messier closet. And what we're starting to see now, and what I think this article starts to speak to, is the patterns are sort of known. It's actually pretty easy to go online and figure out, like, I need to create data pipelines. What do I use for that? I'm in Azure, and then you'll get a white paper on it. Or you can say, you can do a search, and I hope our viewers do it, small to mid-sized business data warehousing Azure, and there's a whole white paper on it. They just tell you exactly how it should be built. I think most people miss that's what consultants are bringing to the table today. They're just reading what everyone spent the last 10 years figuring out. The problem, I think, has been that discovery period. Too much has been introduced. I think the gotcha in cloud today is coming in and building what you had in on-prem, because on-prem does not translate one for one for the way that cloud should work. Cloud has a higher accessibility. I see a lot of people today open up data centers, and all they really want to do is connect to vendors' APIs. That's perfect for cloud. Not so perfect for on-prem necessarily. I think the reason why we hear this, we see data lake, is that concept was like a great buzzword. And then over time, we've actually started to see it solidify and formulate into an actual term and what that's supposed to mean. I was talking to somebody the other day, and I mentioned our lake house. And they were like, what the hell's a lake house? I was like, well, it's a warehouse, but it's in the cloud and it's attached to a lake. And they were like, right. So what the hell's a lake? And I was like, it's just where you pour your data. But before, I think those answers were much more squishy, or people were saying warehouse. I have this radical idea that what cloud kind of opened up was centralized data as a managed platform. You don't actually really need a warehouse. You don't actually need like a transactional DB. You can have all those things in the same place. The data that you'd use for an application is the same data that I would use to fuel analytics. And I don't think I've ever seen anybody approach it that way, where it's get data to a place, treat data based in the situation, the context, the right way. Sometimes you might need something normalized. Location DBs are a great example of that. But most people don't really need highly conformed, highly cleaned data. Most of the people I talk to today can work perfectly within the data that you get straight from a vendor. They just might need it structured slightly differently.
All those old terms like star schema and stuff like that.
Yeah. And you can look at like a traditional warehouse, and everybody talks about like 3NF normalization and standardization and making sure you conform everything. Sometimes that matters. I don't want to put anything in front of you, Rick, that has codes from our vendors or from our customers. So you have to decipher JJ or KK.
How do you see this working in like sort of the master data management space, when you have customer names different ways, and
for
how
me,
do you map that data?
I love the old term data sprawl. And sprawl is great because I think a lot of people think of it in the wrong way. They think of it from just a centralized place, and it just winds up in a bunch of different places. But it's not just sprawl, it's also these silos where people are going and fetching the exact same data over and over again. When you have it in a centralized place, the paths you take in terms of maturing that data into analytics, the transactional application space is right in the middle. It's just about where you start to connect your users. So I can see, we talk about our medallion architecture today, where we're looking at bronze raw data, silver parse to partition tables, and gold, which are what I would consider to be like custom fit data, conform data, final form stuff that end users can use. I can see an application just hitting a table that's just a parsed file that's just populated because you need a couple columns. I can see a data team, because this is what data engineers do. I think it's what the space in which data engineers don't get appreciated in is they work in the enumeration of data or at the grain of the data. And in that space, it's, well, what if I could take 3 different source systems that we've set up ourselves, put that data together and create a custom array for one of your applications, or drive analytics into our Drive app if we wanted to have that capture. It's so much more than just intelligence tracking, but putting it all in one place, making sure it's organized. That I would actually say is probably the biggest challenge. It becomes very easy when you have 50 different source systems, when you're bringing in, 80,000 transactions a second. All of a sudden, your directories just look like a nightmare.
Yeah, and I think people hear you say stuff like this and then think about like, I think they
This guy's a
Probably
nerd.
well, probably a little more of a nerd. But they think about analytics or predictive analytics or things like that. But I think there's another part that sort of overlooked, and that's why Eric's here. Data is sort of the foundation of your house. Mm-hmm. And if the house doesn't have a good foundation, everything else built upon it is going to be difficult. And I've used the analogy again, because I think most of my job is speaking in analogies. Data is sometimes like a bag full of old Apple AirPods with everything's tangled together. If you can make them nice and straight lines, that makes it really easy to build applications.
100%.
Or to get the data you need to make decisions on, like, say, algorithms you're going to write, or AI, machine learning kind of things, as long as the data's in the right spot. How do you think that is going to, like, a better lake or lake house for us is going to work with you in developing applications?
Well, I think there's two different approaches that organizations take, whether they have a data team or they don't. Right? So if you have a data team, an organization is more likely to formulate their data structures first in a way that makes sense in sort of a real world usable scenario, or how these entities actually relate to each other, like orders on a shipment, shipments on trucks, truck dimensions, things like that. If you're in the logistics space, but you sort of identify those real world entities, and then you model your data and your data structures based off of that. And then you build applications on top of it that are highly organized and that allow the users to perform the actions they need to perform in the right ways, versus the other scenario where they don't have a data team or they don't have somebody who's concerned about that. They build the applications first, and then they sort of build their data models around what's easiest to formulate based on what's easiest to engineer. Mm-hmm. And that's when you start getting really complicated, unnecessarily complicated data structures, or you get data structures that are overly normalized or not normalized enough because you didn't really think about how these entities interact with each other. You just thought about like which button the user is going to press and what happens after that, and then the data just kind of followed. So you're right in that if you can formulate your data structures or like a good data platform to begin with, and then build applications on top of that, or even just build processes on top of that. It doesn't have to be applications necessarily, but you could build good processes on top of that and then build applications on top of those processes, with data being that foundation, like you said.
And that's where you start to introduce things like data mining. I think one of the things that I've definitely felt at RPM is a desired force or opportunity available to our business is just the ability to start looking at stuff that they didn't know we had. Mm-hmm. So even when we kind of get back to non-dumping data, capturing stuff that we don't even use today, like vehicle color.
Yeah.
Would be awesome just to be able to take a look at it. We don't have a palette to match it against. I don't know that I can tell you which one is pink. I don't know. I can tell you which one is red. But having that and knowing that it's available, stored, and readily available when we do need it actually sort of changes the game. It also opens up opportunities for discovery. I think for us, like VIN decoding is a big deal considering the nature of our business. Mm-hmm. We've worked with vendors that provide VIN decoding for us in the US, but now we're starting to discover available public DBs that our vendors use. But we're also finding Python packages that just come with native decoders. And now that we're trying to bridge out into the EU, provide VIN decoders for the EU, which has always been a problem for us to try and solve. I think once you start to get into a mindset of where you think about the context of your data and how it affects your users and what services you can offer, that's when you start to see innovation, exploration, people reaching out to like open source packages, people being able to start really thinking about the business in a sense of like what is available to me to see what knobs and dials I can turn to affect the way that our business functions.
Well, not only that, but kind of back to your original question of like, why are data lakes such a big deal now versus when they were created more than 10 years ago? Mm-hmm. I think the cloud has existed much longer than like the general acceptance of the cloud, especially in kind of old school industries like logistics, where it took them longer to adopt cloud platforms. And really, it's only become generally accepted within the last 10 years at all. Yeah. It's hard to take a bunch of people who have been system administrators and database owners and things like that have this hardware on premise and then tell them, hey, you're going to give all your data and all your operations to a third party, and also you're going to have to retool so that you know how to interact with the cloud systems. And so I'm not surprised that it took a while to adapt. But once they did, I think they started seeing the benefits of, hey, I'm a small company that now has access to the same resources as these larger companies that have always had data centers. And you see that in the tooling that's available to us now too. So when you're doing in-house engineering, at least, it was one thing to create an application that had a form in it that allowed users to just collect data that they used to write on paper. And now you have data, people are looking at it. Yeah, you have salespeople who are looking at, the orders that are coming in on a screen instead of a paper, and they're able to go sell it to carriers or whatever. But now we have all the data necessary to create tools that make decisions based on that data, and also run analytics on it to make more informed decisions. But you wouldn't have things like shipment builders or routing engines or pricing engines or anything like that had we not collected all of that data and started making systems like good old engineering, not even AI at this point. Started engineering systems that can use it to make productivity tools essentially for these users to make better decisions off the bat. And then on top of it, you have analytics that allow like managers and people that are sort of running the companies to make business decisions as well.
I was going to say, I think that's the challenge in that you use the phrase old school, but in an industry where, like in manufacturing, we'll say, like, they're 30 years behind in IT tech or whatever, showing them data, the very first thing they want to do is see what's happening in real time and then monitor behavior.
Yeah.
And getting them to change their sort of thought process of like, just assume that works, trust that people are doing their job. What does the information tell us? What decision can we make? That's an evolution, I think, of thought that, up till now in my career, we sort of struggled against sort of our business partners. Just give me this report because I know what I need to see, as opposed to, do you realize that whatever, out of this origin, every time the incident rate of claims is higher, or whatever, like that kind of information to make informed decisions that change a business strategy, right? Not just what's happening right now or what happened last month.
Well, I think you're talking about like a natural evolution that starts to happen, right? Yeah. And I see it actually today in RPM where originally we were really happy to look at the lag metrics and just be like, cool, we're moving this volume right now across our reps, whether it's freight, whether it's vehicle transport. But now we're getting questions, and I think Perk through our COO, John Perk, threw me a great one at one point where he went, so really, how has like our margin changed by origin over the last 2 years by month? And I was like, whoa, that's a whole new level that we have to take our data to. And then you start to look at how it's managed, how we've centralized it, what kind of information you have to split that the right way. And that takes the company's maturity up a level, the way that we think about our company's maturity, but it also forces IT to mature. Because it's not just about serving now what I would say is like maturity of like 1.5. Now we have to serve a maturity of 2 in terms of our data. And that takes more resources, that takes more focus. But it also means you have to be as exploratory as I think the rest of the company wants to be with their data.
Something that is really interesting from a blank canvas point of view is like our historical data, and we bring in data scientists who just don't know anything about logistics, and we just gave them a pile of data and go, tell me what you see. And they make some of the conclusions they make are logical. If you worked in logistics, you'd go, oh yeah, that makes sense. The price of a shipment is primarily dictated by the distance, right?
Yeah.
But they don't know the third element down that list or the fourth. Like, what's the fourth most important thing? And be able to mine that out of there and then maybe change your selling strategy based off of that, or how you build your algorithm to put the shipment together. That's the kind of insight that I think, first of all, outside eyes can bring, but also just I don't need to be an expert at the operational part of the job to just find patterns of data, right?
Yeah.
From raw materials to production to finished products, most everything in our lives travels on a truck. RPM's extensive experience with shipping freight gives us the strategic advantage you're looking for when building lanes and shipping products safely and on time. Our specialized network gives us the capacity to move automotive, aerospace, and consumer manufacturing within any point of the product lifecycle. If you're looking for tailored solutions within your operation cycle, contact RPM today by visiting rpmmoves.com/contact. Now, back to the show.
That reminds me of the article from Rippy AI talking about the future of AI and data in logistics. AI is a huge buzzword right now, especially with the proliferation of ChatGPT and the models, the large language models that are out there. And I went to a conference a year ago, and I was talking about some of the AI stuff we've implemented here at RPM. And I remember someone saying to me, "Oh, you guys actually do AI? We just talk about it."
Yeah.
And I just think it's worth mentioning the difference between AI and ML, because you can use ML, machine learning, to make predictions based off of past data, which you can do for something like pricing or things like that. Or even if you want to predict like stock markets or some things along those lines. But true AI is sort of a reinforcement learning model, and teaching it like a robot to walk or play soccer or to build the best shipments. This is like it's more than a step. It's a big leap in the way things are done. Like right now, if in the world of logistics or IT, if someone would say, "Why did the system do this?" We usually have a way to log it and check or whatever. Yeah. But if you have a neural net that makes a decision, they go, "Why did it do this?" You go, "I don't know, because the brain," right? So let's talk a little bit about how we can use that sort of technology in the logistics space. And specifically, when we talked earlier about the data science we brought here, you said high quality data is important. There was a whole bunch of stuff that had to be thrown out of the data set because people had recorded sort of crappy data. And we've always said bad data in, bad data out, right?
Hashtags.
So it's way more important in AI. So talk about how you feel about that, Dave.
Oh, I mean, so there's ways you can always control for that. But the reality is, and this is a very unpopular opinion. I've heard it frequently. My opinion is very unpopular, but the popular opinion I've heard very frequently has been data scientists love unstructured data. And to a degree, that's kind of true. Mm-hmm. But in my experience working with data scientists, that's actually not always the case. They actually really like very highly cleaned, conformed data sets, things that have high consistency. Because what is 90% of any data scientist's actual job? It's cleaning the data they got from whoever was collecting it.
Right.
No data scientist enjoys cleaning data. Every single data scientist cuts their teeth cleaning data for other data scientists. That's just the way it works. I think ours would tell you the same thing.
Yeah, Vinu had a lot of experience with that when we were first dealing with pricing engines and things like that.
Carol's
spent all his time doing that.
Yeah, and that's all they wind up doing. Now, that being said, unstructured data still has its purpose. For me, it really boils down to like a high consistency where the patterns can be pulled out. So I made a comment earlier about hashtags. We use hashtags for a lot of things in our TMS, to indicate hot loads, to indicate statuses of loads, or to add just a signifier on it so that when we collect the data, we have a better contextual understanding of the shipment. But sometimes people get a little, they put a little English on the tags that they use. So instead of hot, they might type hot.
Yeah.
And sure. But that actually winds up going into creating a lot of anomalies in the way that we want to like build things out. I think processes also matter. I think a lot of people miss this. Adhering to protocol on the carrier rep floor or on the operations floor can affect the way that the data is captured as it moves through those processes. Mm-hmm. So a great example is like making sure that a shipment has a certain number of VINs attached to it. We always have exceptions to it, but sometimes we find exceptions that wind up creating outliers within our models.
Yeah.
And then the understanding of why that affects our accuracy or why that affects the way that a model might function, that becomes you can just correct for that. And truth be told, our data today is a snapshot. All shipments are a silo until we build the way for them to not be. But the shipments we had 90 days ago are not the same shipments that we have today. So each shipment is a snapshot in time. And we're only as good as that snapshot. If you're looking at a bunch of like really badly taken Polaroids of family memories, it's going to look funny. you're going to have misconstrued memories of it when you think about the next time you go on a trip with your family. When we're sitting and looking at kind of misconstrued snapshots of shipments, that means our predictions are going to be as equally misconstrued.
That's a key point.
Right? Yeah, and I think that the level of depth in which we are embedded with the business to understand their processes, to understand the context of the data, results in much better predictions. Even if it's not predictions, I think I have this worm in my brain about one day I want to create a bot that's just an analyst bot. Everybody at every company, I'm sure, experiences the hey, how many of this did we get today? Just a one-off question. Did we get how many VINs came in from Stellantis
ChatGPT
today?
on top of data.
Yeah, 100%.
Right, yeah.
And
tell me how many vehicles came out of Toledo today on this trucking company.
A human being doesn't have to spend time on that. And you can create reports for it, but you can also do things like create a model that sits on top of it so that you have just a quick bot that gives you high-level insights that reaffirm as you're in the middle of a meeting and just making a quick decision on something or having a quick conversation. Hey, by the way, how many VINs did we get from Ford in the last 3 months? Just so I have an idea of the flow of our business. How many of that was an average per week? That kind of high levels, that high level understanding enables somebody, an executive in particular, to make a decision in the moment, or a senior leader to make a decision in the moment. But a human being will spend a lot of time doing that and then have an ownership and mastery over it. But that's not achievable if we aren't embedded with the processes, protocol isn't adhered to, and the data capture isn't the snapshot that we need it to be, or the quality of the snapshot that we need it to be.
Well, I think that Rippy article talks about the challenges of sort of melding your AI systems with your normal your legacy systems or your existing systems. And that's part of it, is if your legacy systems allow people to add bad data, I mean, that's just bad engineering at that point, right? If you have, just as a really simple example, a text box that lets somebody put in 7 million characters and it's just supposed to be a car brand name or something, that's when you start getting bad data in, that then data scientists have to go in and figure out where's the anomaly in my data. And we did see that with our data scientists early on. They had a lot of data that was just input poorly by humans, and Vinu had to basically clean the data. Vinu is our data scientist. He had to clean the data, run the training, find the anomalies, go back, find where the data was bad, and kind of created that anomaly. When we create systems now, in a lot of places I've worked, but especially at RPM, we really think about what are the constraints that we can put on the system to make sure that people are conforming their input in a way that we can use later on. And then you as our data team can use that data and train models off of it. And we have to consider what the output of your model is, so that we don't get a feedback loop where you're training your model based off data that your model is inputting into our system.
Right? This is the ChatGPT problem too.
Yeah, and that is a huge challenge when you integrate development teams into the machine learning systems, essentially, not necessarily AI, but the machine learning systems that data scientists create.
The buzzword of AI is simultaneously sort of scary in the press, but also I feel like business leaders think it's going to solve everything. And so how do we balance, explaining the technology and what needs to be done? Also, while we talked about the data lake earlier, this is a burgeoning space. This is not 25 years. I'm sure AI has been around for 25 years, but its application and the way we're trying to do it now, it's still in its sort of nascent childhood. How do we help educate our partners on, we made the first model, but it was really crappy, right?
Yeah.
So we got to make a second model. Or we made the first model, we did it devoid of knowledge of the business because we want to see what the data said. Now we got to bring in your knowledge, right? But then we have the limitations of the system, and all these things together. That's not an enviable position to be as a data leader. How do you handle those kind of discussions?
Well, I'll tell you, it all really boils down to transparency. as a data leader in general, I always try to approach the problem as I am an unbiased facilitator. I might provide you with something like a solution, but the reality is that we're all collaborators in how we apply the data in different ways. People who are working in our carrier reps will think of ways to apply data that I won't today. And I get caught up, and our viewers have had to deal with this already. I get caught up in talking about data packets sometimes, and that's actually not the right approach and context for the data necessarily. So I always make sure our homework can be checked. And I'm a very big fan of centralize, don't democratize the ability to aggregate and store it. I don't think any transaction should happen with customers, with our vendors, with our carriers, where we're not capturing something that's a snapshot in time of that transaction. Once you have that, whatever we wind up building, the data set should be something that's very clear and easy for even our business partners to be able to go in and take a look at. I want them to catch anomalies that we shouldn't be looking at. I want them to contextualize the data. I don't understand lanes nearly as well as the people that on our third floor do. But that doesn't mean that we still can't provide them something useful. I always like I think we talked about this at one point where I was like, man, I love survival models. And a lot of people look at me and go like, what does that mean? And it's just modeling for a goal. But you look at all of the different data attributes that survive to the end of that model that have a high impact on that outcome that you want. That's where a data scientist today doesn't really have to understand a lot about logistics, but they can walk into a room, run survival models, run regressions, and understand, oh, yeah, these top 3 things, really obvious, but did you know we had these other bottom 3 things that sort of indirectly affect the way that we like price a carrier or the way that we would anticipate how our margin could be impacted. And I shouldn't really focus on margin. I should focus on like, how do I facilitate information that enables a rep to make the decisions that they do. But vehicle weight feels like it's an obvious one, but maybe we don't quite understand how much of an impact it should have on the pricing. Just based on gas surge prices, as well as the distance traveled and the equipment type. All of that affects how quickly what the velocity of that delivery or that shipment is, and how much we're going to spend on it in order to get it from point A to point B.
I think there's a philosophical discussion that could be had about this. Software engineering has always had the black box problem, which is that if users view the systems as a black box and they never understand what it's doing, then you run into an issue where the technology will ultimately fail at some point and the users basically won't be able to do their job, or something catastrophic will happen because they trust the technology too much without actually understanding the manual process that is behind it. Now, with ML and AI, it's purposely a black box. It's making decisions based on thousands or millions of data points and statistics, something that a user could not necessarily do on the fly like that.
Real time.
But I think when you have a decision or some sort of piece of information that is generated by these systems, it should be verifiable manually as well. And users will have to sort of shift their mindset from being able to replicate what it did to being able to verify that it's correct. And that's how we're going to prevent the black box problem with AI. Now, the issue with that then becomes like, if you're a big enough company, then all of a sudden it is making huge decisions for you, and there really won't be a way to verify its decisions without a lot of resources being poured into that verification process. But that's why you sort of start small and you build the AI up. It's not just like one and done, I built this giant AI that's making all the important decisions for us, or a single important decision like how scientists are using it to like map a genome or whatever.
Yeah, exactly.
But you can say over the years, we've had it do this one small thing and we know that that's correct. And then we expanded out its functionality a little bit and we know that's correct. And we expanded it out to the point where we can trust it because we know at each stage it was correct. But that black box problem is going to become more and more of a problem. And it's not like that's new.
It's already difficult to take a piece of code and explain it to like a business user how the code executes, right? I think AI makes it a whole step. I mean,
Oh yeah.
I don't know about you guys, but I had to learn it, right? And I'm not an expert. I don't have a data science degree or whatever, but I had to go and understand how does it do this thing, and it's not like anything we've learned before.
Yeah.
So there's a huge challenge in just like, hey, this is going to solve all our problems, but I don't understand how it works, right?
How do you calculate the land speed of an African swallow, right?
Yeah, it's just an interesting concept. We've talked a lot about AI on top of sort of our data set and how we work, whatever. But there's other ways we use AI every day. Our CEO sent an email out to the marketing leader just earlier today about these different AI marketing tools, and our VP of marketing said, we'll use some of these. And the CEO was like, it's really interesting how we use this and how we might use it in other departments. So I'm like, well, in IT, I mean, don't we use some sort of GitHub thing where it
Copilot. Yeah.
Copilot, yeah. How does Copilot work?
It basically is like it'll generate code solutions for you.
Does it write test classes for us sometimes?
It can.
Yeah.
Yeah.
Just saving time, so speed to market. There's all sorts of ways to use, besides the giant, big, scary build an algorithm or build a learning model that predicts prices or things like that.
Well, but that's also kind of the beautiful thing about where we're at with cloud today, too, because Azure has a turnkey solution that lets us just deploy an LLM, a large learning model, into our environment on top of our data.
Let's do that. Let's go do that.
Yeah, 100%.
Yeah.
Half the stuff that Venu has are turnkey data sets that are public data sets attached to models that you just go out and get. We kind of live in a time, and this is the other thing that kind of gets me, I think, about, because my background isn't necessarily logistics, but within logistics, I think some of this stuff is very new still. But if you go into fintech, not at all. Like when they found out that there was a turnkey method to go get a public data set on the weather, they were like, awesome, go get it. Right. Turn that key now. Right. And so there's a lot of space for us to explore. I think one of the things that I noticed that's very interesting here is how frequently we go to a vendor that we can pay for. When the reality is the vendor's a really great place for us to start, but there may actually be something that we have available to us that we can go turnkey and make available. I think the problem that you are also touching on that I've seen with data science is it's such a highfalutin conversation that as a result, people are kind of afraid to have it sometimes. It introduces concepts where it's like, yeah, I'd love to have a conversation about that. It's about understanding a problem. It's about what tools you can bring to solve it. We live in this weird space. We, as in the three of us on this podcast, live in this weird space where we like to have the conversations about which tool to pull out of the box to solve your problem. But that's not really the agency or the driving conversation that our partners and our stakeholders want to have.
Well, it's not. I think with vendors, it's interesting because a lot of vendors right now, especially as we have this like AI revolution in the consumer space, a lot of vendors are just basically defined by what data they already have. So they may have been a SaaS platform that was just CRUD operations, like a form that people are putting data into, and they have been doing that for 10 years. But now they find themselves with this highly, highly valuable data that can be turned into AI solutions. So now they're an AI company.
Yeah.
And the only difference between us and them and what our capabilities are versus their capabilities is the data they have and only they have. We can go to Azure or AWS or Google and create these models if we had the data to create them off of. But we don't. So you have to go to a vendor for that type of thing.
Yeah.
The other ones are just vendors that sort of mask the underlying, AI, and they just happen to catch people who don't know they can do it.
Well, it's the market's kind of saturated with people too that figure out what we do. So we talk about like the public databases for VINs and decoding. There's always going to be people in the space that I think want to be a little bit more. They're going to go access that public database and then provide you a curated service to provide it.
That's sort of exactly what I'm talking about. And the market is saturated. And I think you'll see in the very near future, that market's going to start constraining to the people that actually have real differentiator technology that they're able to sell people that truly does make a difference. It's not just a pass through that they took a public data set and made it pretty and sold it to people.
I think that's kind of our advantage right now. And that's what's kind of interesting.
But I think, Eric, you mentioned about companies with a lot of data, and then they became an AI company. That's, I think, something I'm just going to use a minute here to talk about RPM. We are uniquely positioned with the millions of vehicles we've moved and the hundreds of thousands of shipments we've done in the past 8 to 10 years from remarketing to OEM to be able to use that data to make predictions unlike anybody else.
Yeah.
And getting this right makes the best pricing for our customers when we go to bid on contracts. It makes the best, most lucrative shipments when we work with carriers. We build the best shipments. All of this stuff, we have access to this. And we're already doing some of this now, but there's so much more inside our own data set, assuming it was clean or whatever. And you're right, bad predictions come from bad data. But as we evolve, we've been doing AI for over, I'd say 2 years now on this data set. It's just getting better and better.
Yeah.
And so
we're even seeing third parties are starting to match up pretty aggressively with us too, especially when we start to kind of pull funny logic on top.
That was a very specific example. But yeah, we have third parties using some of our data to make their own predictions. Ours are just as good.
The supply chain industry is filled with complexities and unknowns across virtually every region. RPM is a disruptive, differentiated, end-to-end transportation provider focused on serving the entire spectrum of both the finished vehicle logistics space as well as the specialized freight transportation space as well. We operate in the United States, Canada, Mexico, as well as continental Europe. So if you're looking for new lanes, new operational structures, and a true partnership dedicated to finding solutions, get in touch with RPM today by visiting rpmmoves.com/contact. And now back to the show.
So this reminds me, I don't know if it's a good time to do this transition because I feel like digital transformation is another one of those phrases that's been around for probably a decade or so, along with data lake. And I think people traditionally would think about digital transformation and then AI, and we're kind of going backwards. But the article Amazon had was about building scalable cloud solutions as part of a digital transformation. And, the IT team here is relatively young. And Eric came in and you had to deal with the challenge of modernizing some of the technology we already had, from simple things like .NET stacks were sort of going to be out of warranty soon, to making it scalable. Like this thing breaks at, let's say, 10,000 bins and we want to do 100,000. How do you fix it? So, digital transformation is not just about we were on-prem and now we're going cloud. It's about making these things scalable. So Eric, talk about some of the challenges you sort of faced when you got here with RPM and getting our tech stack up to snuff for the business we want to do.
I think there's so much you can talk about as far as like not just with RPM, but in
Keep
general.
30 minutes.
Modernizing a tech stack. But with us and with a lot of companies, you come in and you find that, yeah, they're on the cloud. So they're like hosting things on the cloud, but they still might have built their technology as if they are on-prem. And a lot of technology, a lot of the words associated with technology, as we've talked about, like with AI, they're misconstrued, right? So people will say they have certain architectures that they really don't have, like microservices architecture or monolithic architectures or whatever. And then you get in, they're in the cloud and they think, oh, we're in the cloud, so everything's good, right? We can scale infinitely. And that's really not the case, because if you scale infinitely in the cloud without any sort of maintenance or adjustments and scalability in mind when it comes to software development, then all you end up doing is moving this little needle and just like raising the price of your cloud subscription until it's completely unsustainable.
Goes to the right.
Yeah, it's like the magic
digitally
slide, right?
now we get charged by Amazon.
And now all of a sudden you're at like the next tier of your database that is 17 times more expensive than the one you were in previously.
You just keep doing the same thing.
And you just can't keep doing that. And so what you have to do, and what we had to do, was go into our applications and find, one, you had to look at basically tech debt, essentially. So we had applications that were written a few years ago, but they were written in like .NET versions that were end of life. And so we had to update those. We had to add a bunch of testing suites, from unit test to integration test to UI test, just to make sure that when we were working on these legacy systems and modernizing them, we weren't actually breaking the functionality. So early on at RPM, I had heard the phrase building the plane while it's in flight, essentially. And that's really what it felt like, especially with some of these critical systems that absolutely could not go down. Because if we're running hundreds of thousands of dollars a day, if something goes down for half a day, that's a lot of money that basically we just didn't make. Or somebody has to work all night, and that's sort of equally as scary for some people. And so we had to come in and look at our tech stack. We had to update the frameworks we had. We had to add a bunch of testing so that we knew that we weren't going to break anything. And then we really went in and we looked at our data operations. So we looked at the vendors that we were working with and how often we were actually hitting those APIs, which equated to kind of how much money we spent on those vendors. We were doing a lot of data operations unnecessarily. So we were like collecting data for no reason, which can be good if you have a future use case for it, or it can be bad if it's just redundant data collection that really doesn't serve any purpose. We had to look at the scalability of both our cloud resources, our architecture, and our algorithms. So kind of at three separate layers of the software, we had to check for scalability issues because I think at first we had like database scalability issues, and we were just kind of moving that needle up and raising the price of it until we literally couldn't do that anymore. And so we had to find where our database was getting hammered, and a lot of these were low-hanging fruit that just nobody had looked at before because it was a small enough operation that you didn't feel those scalability issues. But when you're at RPM and we're basically doubling the amount of vehicles that we move in 2 years, you're going to see scalability issues, and that's exactly what we ran into. And so we went in, we fixed a lot of the data operations from our software to the database, which helped a lot. We looked at pretty much all of our algorithms to make sure that we didn't have any runaway algorithms that were either hitting vendor APIs too often or just running unnecessarily long like computations on data. So we've spent, I don't know, close to a year just running about 3 separate teams to modernize various systems across our ecosystem, and it's paid off
handsomely.
Future-proof.
It's paid off handsomely.
We future-proofed a couple things.
We did future-proof a couple things. We just finished a project that future-proofed one of our core systems that one of the core underlying systems for probably the next few years.
One of those that when it goes out, we go down.
Yeah, that was like if we wouldn't have done that by the 31st, then our operations would have ended. And that's something you want to tackle earlier than that, though. So
the analogy for that one, we said, you're rebuilding a plane while it's in flight. This was replacing an engine in flight.
Right.
If it went down, everybody would know.
Because the expectation is, well, aren't you doing that already? But we, as technologists, I think, have the challenge today of a lot of what we do is Greenfield. Forget logistics. A lot of what we're actually trying to do is Greenfield work. Even test me, see how many VINs we can process. That's actually a pretty hard challenge to accomplish. And there was a hard cap on that 25 years ago. You knew how many servers you had. You knew exactly what you could process. There wasn't a lot of dynamic concurrency. There wasn't a lot of parallelism that enable services that enabled you to do processing at any level of scale. We're only really coming out of the confusing period of technology for the last 10 years and starting to realize, there's services that are available to us that let us do this. So to us, it's very cool because there aren't a lot of people doing this in the market. There really aren't. When you look at even in our market, when you look at outside of our market, there's only a couple industry leaders really everywhere that are testing this and playing with it, and you know their names. We all read their blogs. And, a secret, they actually kind of paid people to solve that problem for them too. And so the idea that we're kind of playing with that as a concept is still actually very new. It's still very infantile in the industry.
Yeah, we talk about this like, the role of us in the IT organization is it's complex and people tend to oversimplify it. But, we have to keep the lights on. Everything's got to run, right? That's one thing to do. We have to come up with the future. Like, what's the next thing we're going to do? What's our vision? What's our strategy for the systems we have to support what the business model is? And then we've also got to sometimes fix the plumbing. And the assumption that the plumbing's being fixed when the plumbers are working on one of the other two is a difficult thing to sell, right? When I brought you on, I told you this organization, data is going to be seen as plumbing, and we're going to have to sell and market why that's a thing that's important for us here. So,
I put some marketing spin on it for you. Yeah.
So I don't know. I just kind of feel like that brings us to sort of a natural conclusion of the talk about data. Is there anything else you guys want to add?
Data's hard.
Yeah, but that's why we have a job, right?
I mean, I guess I will add that, like, there's a really cool space that we're in right now, and I'm seeing it more and more every day that I'm in here, where we've sort of set ourselves up for success in that we have modern technologies, we have a great development team and a great IT team as a whole, and we're primed to start taking the great ideas of the business and really see them through, as opposed to like, yeah, that's a great idea, but we have so much tech debt, there's no way we could ever do that. I mean, I was just talking to our COO in the hallway the other day, and he's like, wouldn't it be so great that if like some point way in the future we could do this thing where we have a bot that like you could ask a question, it would just create some resource in our system. And I was like, I think you'd be surprised
how close we are
to doing that. Like,
really
there's nothing
future.
Yeah, there's nothing about what you just said that I don't think we could do right now. And so this space where the business has great ideas and we have the team and sort of the foundation to actually act on those ideas it's really exciting.
Yeah.
I want to, because of where we are, we can also do it the other way. Hey, we see the data, we see your processes. We have an idea of how to do this differently, taking an operator hat off. Like, this is an IT sort of answer. What if we build shipments like this instead?
Yeah.
Or something, right? So I think you're right. We are well positioned. I mean, our journey here, I don't want our listeners to think that we're just getting ready to get started. Like, we've made huge strides and got to where we are today. RPM's wildly successful because of a lot of things, and part of it is tech. But we are well positioned to blow it out of the water in the coming, 12, 36 months, to take our tech and the ideas from both sides and actually be strategic partners and not order takers from the business.
Yeah, absolutely.
Totally.
It's the IT paradox.
Yeah.
And thank you to all of our viewers for joining us here with RPM Rundown. I want to thank Eric. I want to thank Rick for joining us for our 5th episode, where we discussed data and technology within the logistics industry. Keep up with RPM on our socials at RPM Moves. Thank you.